welcome everyone to the class of marketing research and analysis. So, as we had discussed in the last lecture about a new concept which comes under the ambit of regression, which was called as logistic regression. So, we learned that logistic regression is a technique which is used when your dependent variable is categorical nature, although the general assumption of regression is that both dependent and the predictor variable should both be continuous. But this is a special case where we understood that sometimes we need to understand in life whether I need to give permission to somebody to join my course or not, or whether it will flood or it will not flood, whether it will rain or it will not rain, whether somebody will be a defaulter or not defaulter. So, there are several occasions in life, should I give should I marry or should I not marry. So, in such conditions where the person is coming with a such a situation or such a condition, he needs to understand that his decisions must be based on certain statistical measures. So, the independent variables, by using the independent variables, he tries to come to an outcome and predict whether he should do it or he should not do it, or it will happen or it will not happen. So, that was a case of logistic regression, right, where we calculated the odds ratio and we measured, and then we found out whether how these variables were impacting, right, the outcome variable. So, we say, and we also understood during that while in the logistic regression that the amount of strength, or you can say the strength of the model, right, through a classification results we understood how strong our model was, how much correctly it was explaining the entire study, right. Similarly, today we will talk about another method which is very close to that logistic regression, or has a similar purpose, you can understand, called the discriminant analysis. As the name you understand from discriminant, so right, what it says, discriminant, to discriminate, right, to separate the one from the other, the good and the good from the rest, or something like that, right. So, discriminant analysis is a similar technique like the logistic regression, but the difference in the between the two is that the logistic regression was performing better when your data is not following the normal assumptions, the normality assumptions, right. But if your data is following a normality assumption, right, all the independent variables are following the normality assumption, then in such a condition then you have two options, right, the logistic and the discriminant. So, the question is, should I use the logistic regression or should I not use should I use the discriminant analysis. So, please remember, if your data is following a normality, right, or the normal distribution, it is always better to use the discriminant analysis instead of the logistic regression. But if your data is not following the normal distribution, then it is better to use a logistic regression instead of the discriminant analysis. This is the basic understanding, right. So, let us start the lecture. So, discriminant analysis is a technique for analyzing data when the criterion or dependent variable is categorical and the predictor or independent variables are metric, right, that is measured on at least interval scales. For example, a school wants to select or reject some students for inter-school hockey tournament. Okay. The school authority used parameters such as age, height, weight and stamina for selecting those students. So, in this case, selecting the students is a clear case where we are using discriminant analysis, right. Now, this is what the meaning of discriminant is. You see, now the men have been separated from the women, or the girls and from the boys, right, through some measures, and this is what this line is the mark of difference or the discriminant, right, it is separating the two, right. So, classification of discriminant analysis. Discriminant analysis techniques are described by the number of categories possessed by the criterion variable. They are 2 group or multi group. So, 2 group discriminant analysis is when the criterion variable has only 2 categories. So, this technique is known as 2 group discriminant analysis. So, do user and non user of social networking sites differ with respect to their age? I want to know. So, this is like a binomial logistic regression, but the condition I have already said is that here the data, the variables, independent variables need to follow a normal distribution, right. If they do not follow a normal distribution, then in the same case, do user and non user of social networking sites differ with respect to their age can be done through a logistic regression. Okay. multiple group discriminant analysis, or comparatively you had the multinomial logistic regression. When the criterion variable has 3 or more categories, the technique is referred to as multiple discriminant analysis, right. Example, do heavy, medium and light users of hard drink, right, differ in terms of their weight or maybe in terms of their heart condition, right. So, we want to check. So, there are several such studies in real life that you want to know, right. Somebody who is a vegetarian or a non-vegetarian, does it impact their stamina, does it impact their weight, right, you want to see. Does, or you can say, is the weight of a person affected by the vegetarian or the type of food, but here the case is slightly different, it is the reversal, right. Here our independent variable is rather a categorical, and the dependent variable weight is a continuous, but just assume the inverse of it, where the dependent variable is categorical and the independent variable is continuous. So, here heavy, medium and light users of hard drink, do they differ in terms of their weight, right. So, can we find out some relationship? That is where we use a discriminant analysis. So, this is a case of a 2 group discriminant analysis, and this is a 3 group multi group, or this is here this case is a 3 group discriminant analysis, right. So, let us see what we exactly do in this case. The development of discriminant functions, the objective of a discriminant analysis is to develop discriminant functions, right, or linear combinations of the predictor or independent variables which will best discriminate the categories of the criterion or dependent variables. Now, what do you understand? It says that a linear combination of the independent variables is done in such a way that it best discriminates between the groups in the criterion variable, right. So, in the criterion variable you have, let us say, heavy and non-heavy, let us say non-heavy. So, if I take the independent variables like age, let us say sleeping habit, right, etc., then how are they helping, how are these helping to differentiate between heavy and non-heavy. So, can I create a equation, a discriminant function, like is like a equation which will help me by putting on the values of x1 and x2, right, to predict whether he will be a heavy person or a non-heavy person, right, in weight. So, examination of whether discriminant significant differences exist among the groups in terms of the predictor variables, right. Determination of which predictor variables, for example, in logistic regression you are seeing the exponential beta, right. The higher the exponential beta, we could say higher is the contribution of that particular variable to the dependent variable. So, if you remember in the last case where we had taken monthly salary and I think it was gender, right. So, we had seen that monthly salary had a higher exponential beta. So, that explained more in comparison to the gender, okay, to explain the effect on the dependent variable. So, determination of which predictor variable contributes to most of the intergroup differences. Classification of cases to one of the groups based on the values of the predictor variables, and another objective is to evaluate the accuracy of classification. This was same like in the logistic regression also, right. So, discriminant function is the linear combination of independent variables developed by discriminant analysis that will best discriminate between the categories, the 2 or 3 categories or 4 categories, whatever you have. But you should not have too many categories also, then it will create confusion. In the 2 group case, it is possible to derive only one discriminant function, but in multiple discriminant analysis more than one function may be computed. Okay. So, very interestingly, as I had given you an example and I said it looks very similar to ANOVA, right. Actually there is a relationship. Discriminant analysis and MANOVA, which has got multiple dependent variables, right. So, in this multiple independent variables, right, and each independent variable has got several factors, right. So, discriminant analysis actually is a reverse, it is called as a mirror image of the MANOVA, that is very interesting. So, discriminant analysis is a mirror image of the MANOVA, right. Why? Because in the MANOVA you had the dependent variable which was continuous and the independent variables were categorical, right. So, you had more than one independent variables, but here interestingly you have one categorical dependent variable and then you have some independent variables which are continuous. So, that is why it is a mirror image, right. So, you see the MANOVA, the criterion is metric and the predictor is categorical, right. However, in discriminant the criterion is categorical and the predictor is metric, right. It has the same assumptions as MANOVA. So, multivariate normality, independence of observations or cases, homogeneity of group variance or covariance. So, in this case covariance. So, right, all these are similar, right. Discriminant analysis permits a MANOVA hypothesis of the test that two or more groups differ significantly on a linear combination of the discriminant variables, right. What it says that two or more groups differ significantly on a linear combination of the discriminant or the independent variables that you have taken, right. Another way to understand is how well can the levels of the grouping variable be discriminated by scores on the discriminating variables. So, how are my predictor variables, how good will they explain the differences in the criterion variable or the dependent variable. Okay. So, look at this interesting table. So, the similarities between ANOVA regression and discriminant. Number of dependent variable in ANOVA you had 1, right. In regression you also have 1, in discriminant also you have 1. Number of independent variable multiple differences. Nature of the dependent variable metric in ANOVA, metric continuous or metric, right, in regression, but here categorical. Nature of the independent variable categorical in ANOVA, metric in regression and in discriminant metric, right. So, this is the basically the relationship between and the difference, right. Now, how does it look like? The discriminant analysis model is defined as a statistical model on which discriminant analysis is based, right. So, this is how the discriminant function looks like. The discriminant score where D is equal to the discriminant score is given by B0 intercept plus C, as you remember the discriminant coefficient or weight, right, or you had the intercept in case of the regression plus B1 x1 plus B2 x2. So, what are this B's, let us say this B's B1 x B1 B2 B3, they are all my coefficients. So, this is my intercept, these are my coefficients B1 B2 B3 and x is my predictor variables or the independent variables. The coefficient or weights are estimated. So, the coefficients will only help me to as in the regression we were doing, these coefficients only will explain me or have an impact on the value of D, correct. Higher the value of B, the larger the impact on D. So, that the groups differ as much as possible on the values of the discriminant function, right. This occurs when the ratio of between group sum of squares to within group sum of squares for the discriminant scores is at a maximum. Now, what does it mean? That if you remember in ANOVA what was the F ratio is equal to the sum of mean sum of square, right, between divided by the mean sum of square within, right. This is what we are saying. So, it says similarly the ratio of between group sum of squares to within group sum of squares for the discriminant scores should be maximum, right. So, any other linear combination of the predictors will result in a smaller ratio. So, this is if this value should be maximum, then only it is the best combination. Okay. Some key statistics associated with discriminant analysis. First is canonical correlation. You will see when I will use the SPSS also, this I will show you. It measures the extent of association between the discriminant score and the groups, right. Centroid, it is the mean values for the discriminant scores for a particular group, right. Classification matrix, it contains the number of correctly classified and misclassified cases. Hit ratio, in the classification matrix when I will show you, the sum of the diagonal elements divided by the total number of cases represents the hit ratio, and it is the percentage of cases correctly classified. I will show you when I show you the table, but understand this terms are very important. The discriminant function coefficients are these are the unstandardized coefficients, are the multiplier of variables when the variables are in the original units of measurement, right. So, these are some of the terms that are associated. So, discriminant score, unstandardized coefficients are multiplied by the values of the variables means your x1 x2 whatever. These products are summed and added to the constant term which is the B0 or the intercept, right, A, to obtain the discriminant score. So, it is exactly like you calculate the regression equation and the score, right. Eigenvalue, for each discriminant function the eigenvalue is the ratio of the between group to the within group sum of squares, right. So, higher the eigenvalue, more is the explanation, right, better it is. Standardized discriminant function coefficient, they are the discriminant function coefficients that are measured or that are used as the multipliers when the variables have been standardized to a mean of 0 and a variance of 1. So, this means what? You have standardized it. So, whenever you standardize a variable, so then only you can compare two different variables at the same level. Why? Because when you have standardized, all the value lies between 0 and 1 and the mean has a 0 and the standard deviation is actually 1, the SD is 1, SD is equal to 1. So, SD is 1 means variance is 1, right, but the mean is 0. So, this is how the standardized value is taken and it helps for comparison, right. Some other terms are like, for example, structure correlation is referred to as the discriminant loadings. So, this term loadings you will understand later on also. This is the correlation between the between two variables. The structure correlations represent the simple correlation between the predictor and the discriminant function, right. So, and then is another term called Wills lambda, sometimes called as the U statistic. Wills lambda for each predictor is the ratio of the within group sum of squares to the total sum of squares, not between. What it is saying? The within sum of square, so mean sum of square be within or total sum of square within, let us say total sum of square within divided by the total sum of square. So, this Wills lambda is actually helping to measure the statistical significance of the model. Okay. Okay. Mahalanobis procedure, a stepwise procedure used in discriminant analysis to maximize the distance between the two closest groups. Mahalanobis distance you are also using in regression also to find out outliers, if you remember, right. So, it helps to measure the distance between the two closest groups, right. Territorial map, a tool for assessing discriminant analysis results that plots the group membership of each case on a graph, which I generally do not use it, but you can, if you want to plot it on a graph and see. So, that is through the territorial map. Okay. So, what are the steps involved? First you formulate the problem, estimate the different discriminant function coefficients, determine the significance, interpret the results, okay, and assess the validity. Now, step 1, how do you do that? So, the first step is to formulate the problem by identifying the objectives, criterion variable and independent variables. So, what is your dependent, what is your variable, what is your independent variable and what is your objective of the study, right. First you need to formulate. So, the criterion variable must consist of two or more mutually exclusive and collectively exhaustive categories. So, there should be two categories which are mutually exclusive, very different, and collectively exhaustive means they are all the respondents are lying in these two categories only, right. The sample may be divided into two parts, right. One part called the analysis sample is used for estimation of the discriminant function. The other part called the validation sample is used for validating the discriminant function. So, one part is used for estimation, the other part is used for validation. So, if you have let us say 200, so you can divide into two parts of 100 each, one to estimate the discriminant function and the other is to validate the discriminant function, right. The role of both part samples are interchanged, then analysis is repeated. This is called cross validation, which you will see later on, right. Second, how do I estimate the discriminant function coefficients? Two broad approaches are there, right. One is the direct method and the other is the stepwise method. By now I think you have understood what is the stepwise method. In regression also I had explained. The direct method involves estimating the discriminant function so that all the predictors are included simultaneously, enter, and as in regression you are using the method enter. Okay. This method is appropriate when it is based on previous research or theoretical models. Okay. In stepwise method, the predictor variables are entered sequentially based on the ability to discriminate among the groups. So, you may use a forward method or something like in stepwise. In the regression we are using forward regression, backward regression, similar, right. Then determine the significance of the discriminant function. It would not be meaningful to interpret the analysis of the discriminant function estimated where if they were not statistically significant. So, null hypothesis in the population, the means of all discriminant functions in all groups are equal and can be statistically tested. This test is based on the Wills lambda, which I already said. What it said? The within the group variance divided by the total variance, right. If several functions are tested simultaneously like in multiple discriminant, the Wills lambda is the product of the univariate lambda for each function. So, that you need not worry, if you are doing it by hand it is a separate thing, but we do not do it by hand, we do it through SPSS. So, it gives us, or any software, it helps us. The significance level is estimated based on a chi-square transformation. So, this is something which is which will be provided, the chi-square value, which helps in predicting the overall model's significance, right. If the null hypothesis is rejected, it would indicate significant discrimination, then one can proceed to interpret the results. Let us see this. The fourth step is to interpret the results, right. So, the value of the coefficient, right, for a particular predictor variable. So, whatever the coefficients you have x1, x2. So, this b1, b2, right, we are talking about this, right. So, the value of the coefficient for a particular predictor depends on the other predators included in the discriminant function. So, they are somewhere related. Okay. The sign of the coefficients are arbitrary, but they indicate which values result in large and small function values and associated them with the particular groups. Now, what does it mean? That means in simple terms you need to understand that the slope values, right, with the the variables together will help in discriminating, they will give you the discriminant score, right. So, this discriminant score which will come, this will finally help you to discriminate whether this will come into the category 1 or category 2, right. This is what it means. The relative importance of the variable can be examined by the absolute magnitude of a standardized discriminant function coefficient. Higher coefficient contribute more to the discriminant power. That means, a higher coefficient is better in explaining that these two are clearly different, right. If the coefficient values is less, smaller coefficient is there, then you cannot exactly say that there is a clear cut difference between the two groups, right. Some idea of importance can be obtained by examining the structure correlations also called as canonical loadings or discriminant loadings. Now, remember, greater the correlation, the more important is the corresponding predictor, right. So, let us see, and finally, we will come to the validity of the discriminant analysis. So, to check whether the study is valid or not, what you should do is divide the data into two subsamples, one analysis and the other is for validation, right. So, this will help you in the estimation, right, and this one for validation. So, the analysis is used for estimating the discriminant function and the validation sample is used for developing the classification matrix. Now, I will show you in the regression logistic also you had seen classification matrix which was helping you to calculate the hit ratio, which was telling what percentage of the values were predicted correctly and thus how strong the model was. For example, in the last case if I remember, our predictor our model they had classified 91.2% of the cases correctly in the logistic regression, if you remember. So, here that is what it helps you to find out the classification matrix which tells you whether the model is sufficiently explaining the whole process or not. The discriminant weight which is estimated by using the analysis sample, right. So, analysis sample are multiplied by the value of the predictor in the holdout sample. So, this is the analysis, this is the validation of the holdout sample to generate the discriminant score for the cases in the holdout sample, right. So, one you are using for validation, the other you are using for estimation. If you do not do this also, it is not a very great deal, you can still get to know, but the point is if you validate it, it becomes more rigor, right. What is this hit ratio? Hit ratio is determined by summing the diagonal elements and then dividing by the total number of cases. For example, so let us say A, B, C, D, right. So, this was a case of yes, no, right, and whatever was. So, this plus this, right, this plus this divided by the total, right, by the total number of cases. It is helpful to compare the percentage of cases correctly classified by discriminant analysis to the percentage that would obtain by chance. So, what it says is classification accuracy achieved by discriminant analysis should be at least 25% greater than that obtained by chance, it should be at least 25% greater. Now, how do you conduct the discriminant analysis? So, for this example move the dependent variable into the grouping variable. So, let us go to the slide straight away. So, this is a model where I will show you. So, there are two cases, variable view, if you go to the variable view. So, status of people who are successful and unsuccessful, right, and What is this? The level of IQ they have, the level of guidance given to them, and the income of these people, right, the family income or something. Now, we want to see whether the IQ, guidance and income, does it predict the status of a person, whether he will be successful or not successful, right. So, we are interested, there are 3 independent variables and 1 dependent variable which you can see, right. So, there are only 2 cases, 0 and 1. So, 0 is your case of successful, 0 is successful, 1 is unsuccessful. Okay. Now, I want to run a discriminant equation, discriminant analysis. So, first you can check for normality of the data, and if it is following normality, then you will automatically go for discriminant analysis. So, how do I go? Go to classify, because it is a classification technique. So, discriminant, right. What is my grouping variable? Status. So, what is the range? Minimum is 0. So, minimum is 0 and the maximum is 1. Okay. Continue. Now, what are the independent variables? I am taking all the 3, guidance, sorry. Okay. Now, statistics. What do I need? I need the means. I think if you go to the PPT also, it is everything is mentioned here. So, for example, you see, move the independent variables, select the independent variables, click on statistics, go to the box M, right. So, everything is given here, right. So, let me show again, let me go back. Okay. So, I need the box M, right, and I need the unstandardized weights, right, and the within groups correlation. So, I need this. If you are interested to save, you can predict the group membership, which group does it come to, the successful group or the unsuccessful group, right, and the probabilities, right. So, this is all we need and I go to OK. So, look at it, if what I am getting is, I have got n is 90 and all, there is no missing case, right. Now, if you look at this group statistics, so successful people and unsuccessful people, their IQ level, the mean and standard deviation for IQ, guidance and income for successful people and answer is given to you, right. And as you can see, the IQ for successful people is more than the unsuccessful, the guidance is more again, and income is also more, right. So, can we now say which one out of this, maybe all are impacting positively, but how much or which one is the most important one, right, let us say. Now, if you look at the correlation, right. So, correlation between IQ and guidance is 0.338, IQ and income 0.005. Similarly, between guidance and income is 0.053. So, the strongest correlation we find is between IQ and guidance. Okay. Now, let us go down. So, if you see this box M test, now this test the null hypothesis of equal population covariance. So, the box M test should be not significant, right. That means, the value of the box M test, the significance value should be above 0.05. That means what? The null hypothesis says there is no difference in the group variances and population or the covariances matrices, population covariance matrices, and this is coming true. You cannot reject this null hypothesis, and this is what is required, right. So, this should always come above 0.05, right. Now, look at this canonical correlation value. So, this value, if you see, this is exactly similar to or very much similar to the R square value. So, if I take this value, this is similar to the R, and I should, if I take the R square, so that means what, 0.727 square is equal to something around 50 something will come, right. So, that is my R square or the explained variance in the model, right, when I am having one predictor and 3 independent one criterion and 3 predictor variables which we had in this model, right. Now, the Wills lambda, which is a test of significance, is significant. This means what? It tells that the overall model is significant. Okay. Now, let us go to the file. So, this values I put it there, I will show you. So, suppose let us go back to the problem. A researcher wants to see the influence of IQ, guidance and income on the result status, success or failure, right, of students. IVs are given, DV is given, success or failure. Okay. Now, how do I report? So, discriminant analysis was used to conduct, let me show you the first this values, right. So, the eigen values is 0.727. So, if I take this and square it, I am getting this value, right, 52.85. So, this discriminant functions accounted for nearly 53% of the variance in the student result status, confirming the hypothesis, right. Now, if you look at this Wills lambda, it is saying it is significant, right. So, here you see the overall chi-square test was significant, Wills lambda is 0.471, chi-square is 65.125, degree of freedom is 3, and this is what you have to the canonical correlation and significant 0.001. So, the overall model was significant, right. So, the overall model was significant, this value you have to mention. Now, the third table was this Box-Sum test, whether I have mentioned it here or not about the Box-Sum, let me see. If it is not mentioned also you need to mention, right. So, from the Box-Sum test we found that the null hypothesis that the difference among the groups, right, there is no difference among the groups exists was found to be true, that is also you can report. Okay. Now, coming to this standardized canonical discriminant function coefficients. Now, if you look at this, right, these two table, this tells you the importance of each predictor variables to the criterion variable. Now, this has a different role, I will explain this. So, what it is saying IQ income has 0.811. So, income affects the success or the failure rate highest, the highest impact is of income, right. So, next is IQ has a 0.442, right, and third followed by guidance. So, it is income, then guidance and then IQ, right, income, guidance and IQ. Okay. Now, what is this table saying? You will get this table if you see, if you go back to the output file. So, if you see this, so you have seen this table right now, right, and we are talking about now this table. So, this table is the table which I am requiring again here. So, this table says, now I want to find a discriminant score, right. So, my equation will be built on this. So, you see, so minus 17.413 plus, right, 0.056 IQ plus 0.037 guidance plus 0.015 income. So, this is what the discriminant score you can, this is how you calculate the discriminant score, right. So, by putting on the actual values of IQ, guidance and income, now you can predict the discriminant score, and accordingly you can see the cutoff value is always 0.5. So, 0.5 it is, let us say it is above 0.5, then it moves towards 1, if it is below 0.5 it moves towards 0, because there can be only two values, right, 0 and 1. Now, look at this classification result. So, this is the one which tells you the hit ratio. Now, what do you do here? Now, you see 55 cases originally they measured, the status is successful, unsuccessful, this is observed, right, this is observed and this is predicted. So, observed successful was, let us say which was successful and they were actually predicted also were 55 cases. 7 people who were observed to be successful, but you had predicted that they will not be successful is 7, right. So, this is an error. You had predicted, you have seen that they are unsuccessful, but you have predicted that they would be successful. So, again 2 cases which are wrong, it is like a type 2 error, okay. And this is where you have unsuccessful and it is actually unsuccessful. So, it is again correct, right. So, now you see this 55 plus 26 diagonal, right, divided by the total. How much is the total? 60 plus 20, 80 plus 20, 90. So, how much it is? 50 plus 20, 70, 5, 81. 81 by 90 is equal to how much? 90%, right. So, that is what it says here, 90% of original cases were correctly classified, right. Cross validation is done only for those cases in the analysis, right, only for those cases in analysis. In cross validation, each case is classified by the functions derived from all cases other than that case. Now, let us see in this case what is happening. 55 cross validation, 55 plus this 25, right, is how much? 55 plus 25 is 80, right, divided by the number of cases. How many number of cases? 90. So, equal to what? Around 88.9%. So, 88.9% of the cross validated group cases correctly classified. So, what basically it does, you need not bother about it. When you do this discriminant analysis on the software, it will help you to get these tables, and once you understand these tables, you can even calculate the discriminant score, and you can predict whether the model is sufficiently explaining or it is not explaining, right, and thus after that you can report it, right. So, once you do this, it helps you in very clearly discriminating between two or more than two groups, right. So, and accordingly draw an inference in the study, right. So, this technique has a very high utility, and it can be utilized. So, you have understood by now that logistic regression and discriminant analysis both are similar kind of techniques. The only difference lying in the data's behavior, whether it is a normal data or not. If it is normal, then discriminant analysis; if it is not normal, not following a normality condition, then it is a logistic regression case, right. Well, this is all for the day. Thank you very much.